I want to congratulate the Environmental Division of AIChE for its 50th anniversary. Um, think about 50 years ago, 1970. That was the year when the US EPA was established. The air and water were a lot dirtier than they are now. The Cuyahoga River near Cleveland had caught fire just a few years before the EPA was established. There were all types of smog problems in the major cities. And in general, the quality of the environment that we lived in was not very good. The environmental division's work and the work of the members of the division and of chemical engineering has clearly played a very big role in the improvement that we have seen in the quality of the environment that we experience today. Lots of different technologies have been developed and implemented, ranging from catalytic converters, methods for cleaning water, understanding the fate and transport of pollutants over urban areas. And these are only some of the solutions that have been developed, implemented, and have been widely successful. So if we look ahead, one thing to question is, are we done with solving environmental problems? And the answer obviously is no. What we have learned from the environmental solutions that we have found previously, these technologies that I mentioned, is that environmental problems have a unique ability of shifting in terms of the domain in which they are. So let me just share my screen and show a couple of slides to tell you what I'm talking about. So environmental problems in general tend to shift in space, in time, between flows and across disciplines. There are many examples of this. We may solve an environmental problem, in one location by raising the height of chimneys. We may reduce acid rain, but really it just gets shifted farther away. There are similar problems of shifting problems in time. Between flows is things like we may reduce energy use, but we may need more water. And across discipline is situations where we may have a technology that is more efficient. So from a technical point of view, the problem may be solved, but the problem really just becomes a behavioral and economic problem because the technology may be more efficient and therefore cheaper, and therefore consumption may go up. In addition, sustainability requires staying within nature's capacity. So these are the characteristics due to which environmental problems seem like a moving target. And they have been, even though there has been a lot of progress. As you can see in the slide here, we have moved from, local manure pollution in the cities when we were using horses to smog, acid rain, and now global climate change. So engineering will need to solve these kinds of problems. And the question is, will it be able to do that? So there are many things that I think need to be worked on in terms of the future, but I want to focus on only one of them, which I think is sort of a fundamental problem. And that is a root cause behind a lot of the challenges that we have seen with respect to environmental degradation. And this issue has to do with the relationship between engineering and nature. The fact is that all engineering activities, all human activities for that matter, depend on ecosystems. They provide us all kinds of goods. They are sinks for our wastes, and they provide all sorts of services, including managing the quality of or regulating the quality of air and water, and providing us food, regulating the climate, even regulating pandemics for that matter. As is shown in the slide, you can see that if industry may be emitting various pollutants, carbon dioxide, sulfur, nitrogen oxides, and so on, vegetation can take those pollutants up. And it can provide oxygen in return and biomass, and also provide for water in the watershed, provide recreational opportunities and so on. Similarly, wetlands also are able to clean up water and provide lots of services, back to society. The problem is that, in engineering, like pretty much most disciplines, that have developed over the last 300 years or so, we have ignored the role that ecosystems play. We do not take into account their role, and we basically take them for granted. We ignore that nature has a capacity to handle our resource use and emissions, but If we exceed that capacity, then it results in ecological degradation, as we have been seeing all across the world today. So what we need to do for that is to take into account explicitly the role of ecosystems in terms of supporting the different goods and services that it provides. And here is a diagram that shows, the vision that we are pursuing, is where we take technological and ecological systems into account explicitly, account for the fact that ecosystems can take up various pollutants and convert those pollutants, convert the waste into natural resources, goods and services that we need for our industrial activities. Examples of these types of ideas, are, imagine this manufacturing process over here, which is along the Ohio River, it is burning natural gas and maybe coal, it is generating various types of emissions. And the green area, could have vegetation that can take up a lot of this pollution, and the blue area could have a wetland that could treat the water that is coming out from this plant. So, nature does provide goods and services. Let us work with nature. Let us learn how to work with nature so that we can come up with mutually beneficial solutions. So in this example, what I'm talking about is, in a way, treating nature as if they were unit operations. We all know the concept of unit operations, reactors, distillation columns, pumps, etc. But what I'm saying is that we need to take into account the role that ecosystems play in supporting our industrial activities. And if we develop these types of integrated designs that explicitly account for the role of ecosystems, what we have been finding in our work is that there are many opportunities for solutions that are environmentally superior and economically cheaper than the solutions that we are able to find with a conventional technocentric point of view. So there are lots of research opportunities, lots of need, to work in these kinds of areas to discover these sorts of win-win solutions. There are plenty of challenges, needless to say. Nature is intermittent. We like our technology to be, predictable and fixed. There are also many challenges from economic points of view, from policy point of view, and so on. But these are the things that I believe are central to addressing the environmental and sustainability challenges that we face today and that future generations are likely to continue facing. So, we've been applying these kinds of ideas and have, considered biodiesel manufacturing processes, chloralkali processes, watershed management, even design of residential systems, and so on. The key message over here is that, as you may have seen a recent documentary by David Attenborough, where he says that we human beings need to realize that we are not apart from nature, but are a part of nature. That, I think, is the biggest challenge that we face, and that's likely to keep the environmental division very important and busy, for the next few decades. Hopefully, it will not take us 50 years to solve these challenges that we face, but 50 years can go by relatively quickly. It's time that we all start focusing on some of the biggest challenges that humanity faces today. Chemical engineering and chemical engineers have an opportunity and the ability to address these challenges. But it is important that we also improve our ecological literacy, because that is the system that has been degrading, and that is the system that we need to learn from and be able to mimic to develop integrated systems that are both sustainable and resilient and can ensure prosperity of current as well as future generations. So congratulations once again to the Environmental Division. Thank you.